In today's tutorial, we will discuss the retrosynthetic analysis of this target molecule. Let's see how we could synthesize this molecule. First of all, let us have a look at the functional groups we have here. We have a hydroxyl group, and very often we will be in need of protecting groups. In this case, on the other side of the molecule, we have an acrylonitrile moiety. It is a cis olefin, and a good way for selectively get to the cis stereochemistry is the catalytic hydrogenation of an alkyne. So the alkyne would be the simpler structure, and we need a catalyst, transition metal catalyst for this transformation. Maybe Rene nickel or something like that. So, from this molecule, we see or we notice a strategic bond here. We can disconnect into the alcohol part with acceptor reactivity here, and on the other hand donator reactivity at the alkyne. This is the natural reactivity, since the terminal alkyne is easily deprotonated, and then we have the nucleophilic carbon and ion. So let us translate those two synthons in synthetic equivalence. Acceptor reactivity is translated into a leaving group at this position, and here for that this acetylenic moiety we just have the terminal acetylene. What we need is a base but for the OH group, we will need a protection. So let's see about X. X could be a chloride or a paratoluene, a tosylate. So a sulfonic acid ester, which is also a good leaving group. Protecting groups, possible protecting groups. Well, let's see. For instance, the so-called THP ether easily set up by using this cyclic enol ether and under acidic catalysis just let this react with the alcohol. Or we could use a silyl protecting group. A TMS group with 3-methyl group is easily hydrolyzed again. More expensive but very reliable is the TBDMS group, tertiary butyl dimethyl silyl protecting group. So, well, one could have the idea, why not using a benzyl protecting group? Because a benzyl protecting group can be hydrogenated off. Deprotecting is usually done by a catalytic hydrogenation. We have a catalytic hydrogenation in the last step, but there are somewhat more vigorous reaction conditions. Active catalyst, higher pressure to hydrogenate an aromatic system. Under these conditions, usually also an olefin would be hydrogenated. So, therefore, we should rule out the benzyl protecting group. Well, okay, now we have to think about from which starting material can we get to this molecule. Well, the most or the cheapest starting material certainly would be this pentane diol. Okay, so the plan would be protecting one of those two OH groups. Well, this does not work selectively if you add the protecting reagent 1-to-1. As a result, you will usually have 50% of mono protected, 25% of bis protected, twice protected, and 25% of the starting diol. Nevertheless, it is a cheap material, and those three ingredients in the reaction mixture, the diol, the monool, and the diether, are easily separated because of the big difference in the polarity. So, okay, starting here, protecting either as THP ether or as silyl ether, then transforming an OH group into a leaving group, deprotonating the acetylene, and let this react as the nucleophile with this protected system. Then we are here, and in the final here with an OH with a protecting group here. Well, okay, hydrogenation will give the cis olefin, and deprotection maybe in the last step. Thanks for listening.